The history of successful transshipment is a simple one. An anchorage is established at the intersection of import or export points. Small vessels import from larger vessels or export to larger vessels. These small vessels load or discharge in shallow waterfront points close to road or rail. When commercial lighterage and transshipping activity grows, ports are then constructed in the same area. As ports grow in size, towns and cities form around them. Hong Kong and Singapore started as transshipment centres. In the last 50 years, for bulk transshipment, open storage areas or large storage sheds had to be built on prime waterfront land areas, equal to the capacity of an export vessel. Then large expensive jetties would be built out to deep water, these days around $1 billion. These jetties would also be expensive to remove at the end of the mine life, which is now an environmental requirement. Most transshipment methods are generally restricted to sheltered inshore coastal waters, but dust and transportable moisture limits are common problems. Operations are restricted to maximum wind speeds of 20 to 25 knots. This case shown has spillage of toxic materials from the grabs and pollution of the water. Most transshipment operations are restricted to maximum wave heights of 2 to 2.5 metres. Indonesian export coal has already surpassed Australia. Most of Indonesian coal is transshipped from many sources along their coast and upriver. Their logistics cost is a fraction of Australia's. Whereas Australia is hampered by inflexible traditional thinking. Only 3 Cape-size ports along Queensland's 7,000-kilometre coastline. A difficult and costly EPA permitting system, particularly relating to coastal and dredging items. An inexpensive workforce, which results in costly infrastructure. Indonesia leads global export of thermal coal and is constraining the global price according to the Selva report in July of 2016. Indonesia export coal is growing at 13% per annum, twice that of Australia. Indonesian transshipment systems, while very cheap in labour costs, are environmentally poor, causing dust and spillage. They cannot handle rough weather, and rain adversely affects the transportable moisture limit. Can Australia realistically compete? Sea Transport Logistics, with a successful track record in dust-free transshipment vessels, has focused on total weather and environmental solutions, which can be globally competitive for bulk exporters, incorporating the use of small, shallow harbours and competitively priced, Asian-built, Australian-designed transshipment vessels. To minimise the small harbour footprint and depth, we use the patented quad-screw stern landing vessels, SLVs, that are highly manoeuvrable, shallow draft and can carry a wide variety of bulk cargoes or containers. These vessels require the smallest harbour footprint. Stern landing vessels remote area berthing using a single pile. The vessel comes alongside the pile amidships and loops the 1.5 metre diameter pile with a mooring rope. With the outer starboard engine slow astern, the stern will swing round slowly, irrespective of the tidal flow, to place the SLV ramp onto the shore concrete ramp. The vessel will not need engine power to stay on the ramp during cargo operations. However, in exposed wave areas, a mini-port has to be constructed. This plan view diagram shows a standard mini-port and the SLV manoeuvring into the loading position. The curve of the wall is in the direction of the littoral drift. This chart shows the dimensions for a mini-port for vessels of ascending sizes. Note the much greater volume required for the cheapest CapEx tug and barge solutions exceeds the SLVs by 300%. This is Bing Bong Harbour in Northern Territory, designed by Sea Transport for an STL vessel in 1988 and still operating successfully, exporting lead zinc. Attempts by Western Desert Resources to use this harbour with the cheapest CapEx, tug and barge in early 2015 with iron ore, which resulted in failure and the loss of $88 million. If you think good advice is expensive, try bad advice. In this bold change to transshipment thinking, Sea Transport Logistics has focused on small, shallow harbour transfer solutions with minimal storage on prime waterfront land, using shallow draft feeder vessels to feed out to a floating harbour transhipper, FHT. For minerals export, attached to the small harbour is a negative pressure shed, which the feeder vessel backs into and is loaded. The feeder has a roller hatch preventing any dust blowing or any rainfall affecting the transportable moisture limit of the cargo being exported. The former waterfront storage of bulk cargoes is replaced with a small footprint transfer shed with little or no dredging requirement. The feeder proceeds out to the patented Floating Harbor Transhipper and docks stern first into the aft end, and the feeder cargo is discharged into the FHT or directly into an export vessel if one is alongside. The FHT replaces the need for large storage sheds ashore and provides a safe dock undercover with no grab spillage, dust or TML problems. The FHT has backup systems in case of equipment failure. Queensland, for instance, only has 3 ports for Cape-size ships for 6,973 kilometres. In effect, 1 Cape-size port for every 2,324 kilometres on average. Abbott Point, Hay Point, Gladstone. These 3 ports are constrained by tide and vessels cannot sail unless it is high tide. Also, Cape-size ships cannot access Asia from these ports via the shortest route through Torres Strait and then have to go round the east coast of Papua New Guinea. Cape-size FHTs can safely work and sail capes around the clock at these 27 locations. This then averages a Cape-size port every 258 kilometres, including sites on the western side of Cape York, the shorter route to Asia. Transshipment is already working at Bingbong and Karumba. Other transshipment operations are being considered at Cooktown, Arakoon, Burketown and the Northern Territory Queensland border area are suitable mini-port sites. The following gives compelling evidence why mini-ports and waterway transportation should be a priority. Five ports have sold in Australia at 25 to 27 times multiple, but only for lease, whereas many ports are generally freehold and strategically positioned for existing and future growth opportunities. Sea Transport has an 18-metre catamaran survey vessel with a 1-metre draft and equipped with multi-beam structure scanning of the seabed, including vegetation and composition. Sea Transport has designed a 35-metre vessel with multi-beam sonar, sub-bottom profiling, hydrographic and benthic survey equipment and bed leveller. This vessel has an 18-inch pump capable of trailer, suction, side casting and cutter suction works to 8-metre depths. In a nutshell, this mini-port infrastructure strategy is relatively low capital investment versus high revenue potential, developing a functional port and transshipment model at 20 to 30% of the capital cost of a fixed terminal. Based on a common user model, the earning potential against capital is very attractive. The Australian infrastructure story. There is an abundance of regional farms and mines, but lack of port infrastructures. All communities are now seeking a smaller environmental and dust-free footprint of transshipment ports, and the Sea Transport solution is world's best practice. Waterfront land is prime. This is a paradigm shift in thinking, where we are taking the port to the products instead of the other way around. Innovative mini-ports thinking by Sea Transport Solutions. Mini-port infrastructure strategy, a compelling operational and environmental solution for the 21st century.